A quick legal framing. Much of what I'll discuss will touch on future direction, concepts, and areas we're exploring. A lot of this is my own perspective on the topic. This presentation is not a product announcement. It's not a commitment to deliver specific features and not a release date roadmap. My goal is to share how I'm thinking about AI in the Niagara framework and where I believe it can create practical value for real building automation work. So before I get into how I think about AI and building automation, I want to briefly explain the lens I'm looking through. If you saw my presentation this morning, you kind of know this story. I started my career on the systems integration side and spent about 15 years there. I started in field, installing sensors and actuators and controllers and JACEs. I moved through checkout, programming, service, team leadership, engineering, and project management. After that, I spent about 5 years on the owner side, helping oversee building automation across a national portfolio. And since this is ControlsCon, I'll add that during those years, I was a Cochrane Supply customer. So this community is not unfamiliar to me. In fact, there might be people in this room who supported some of the buildings I was responsible for. That owner side work changed my perspective. A single building demo is one thing. Supporting many buildings consistently, securely, and responsibly, that's something else entirely, especially when no two buildings are mechanically or control-wise identical. And for the last year, I've been at Tridium as the product manager for the core Niagara framework, and with increasing alignment with Niagara Cloud Suite and the broader Niagara ecosystem. So when I talk about AI in building automation, I'm looking at it from three angles. The system integrator trying to deliver and support the work, the owner trying to manage operations and risk, and the product side trying to make these capabilities more practical, secure, repeatable, and scalable. So that's the perspective that I'm bringing to this conversation. So let's name the question directly, because it's probably the question that many of you have. What is Tridium doing with AI? That's a fair question. AI is moving quickly. Customers are asking about it. Integrators are asking about it. Owners are asking about it. And everyone is trying to separate what's real versus what's noise. But for me, the better question is not simply, is AI interesting? Because of course it is. The better question is, where does AI create practical value in real BAS work? That's the lens I want to use. For system integrators, the question is, can AI help deliver better systems? Can it help with troubleshooting, commissioning, documentation, programming support, and understanding systems faster? For operators, and I'm using that term broadly to include building engineers and maintenance teams, can AI help them understand what's happening faster? Can it help clarify some concepts that maybe they're not as familiar with? Can it help make alarms, histories, and system behavior easier to interpret? For building owners and property teams, can AI help improve outcomes? Of course, energy, but also comfort, reliability, risk, uptime, and operational consistency across buildings. And for developers and partners, can AI help work with building data more efficiently? Can we make it easier to build useful tools and services on top of trusted building data? So that's the standard I want to hold this conversation to. Not hype, not magic, real value in real workflows. That's how I believe Tridium needs to think about AI in building automation. So before I talk about where I think AI creates value, I want to explain why I think we have to stay grounded. This is not because I'm pessimistic about AI. I think that AI is going to matter a lot in building automation, and I'm very excited about that. But buildings are not clean room demos. They are physical systems serving real people with real constraints. And when we apply AI to those systems, especially if we're talking about optimization and operational recommendations, we need to respect that reality. So, first, buildings are complex. No two buildings are alike. Even in a large portfolio, and I could have two buildings that were built right next to each other, close to the same time, you can have different mechanical designs, different control sequences, different naming standards, different contractors, different ages of equipment, and different operational habits. So that doesn't mean that AI can't help. It means that AI has to deal with actual building diversity, not an idealized version of it. Second, these are physical systems. A building is not just a data set. Equipment wears out, sensors drift, dampers bind, actuators fail, differential pressure tubes dry rot and fall off the pressure sensing ports of terminal box controllers. Points get overridden. So a strategy that looks smart against clean data can become very expensive against dirty data. Third, outcomes are site-specific. A reset strategy that makes sense in one building may not make sense in another. Occupancy, climate, space use, equipment design, ventilation needs, humidity control, and owner expectations all shape what better means. So real optimization cannot be one size fits all. It needs building context. Fourth, buildings are operationally sensitive. These HVAC systems are not just heating and cooling. They support ventilation, comfort, humidity control, airflow, pressure relationships, code requirements, reliability, and sometimes critical operations. So if we optimize the wrong thing or optimize based off incomplete context, we can move from saving costs to instead adding costs. We might reduce energy in one place, but create comfort calls, maintenance issues, alarm storms, or operational risk somewhere else. And that's why I keep coming back to people. There's also an economic reality here. Energy matters, and we should absolutely improve energy performance where we can. But in many buildings, the larger value is tied to operations, uptime, maintenance, comfort, risk, and the people responsible for managing all of it. So if AI helps an integrator troubleshoot faster, helps an operator understand a problem sooner, or helps an owner avoid disruption, that's real value too. So when I say we need to stay grounded, I don't mean that we should be timid. I mean AI has to respect the complexity of real buildings, because in this industry, value comes from context and trust. And if we get that right, AI can become a very powerful tool for the people responsible for making buildings work. And that leads to directly how I think we at Tridium should approach AI. After thinking about the realities of our industry, our answer is straightforward. We apply AI where it creates practical value, not for the sake of saying we have AI, but to help real people do real work in real buildings. My first goal is to augment expertise, improve understanding, and accelerate outcomes. What does it take to do that? First, it needs to be purpose-built. Building automation has unique challenges. We're dealing with physical systems, operational risk, and decades of accumulated domain knowledge. So the goal is not generic AI looking for generic problems. The goal is AI capabilities designed specifically for building automation workflows. Second, but not of secondary importance, is it has to be secure and trusted. If AI is going to interact with building data and workflows, then security, permission, governance, and customer control are essential. Your data, your control, our responsibility. Third, it has to be human-centered. I do not see AI replacing system integrators, operators, or engineers. I see it helping them understand systems faster, troubleshoot more efficiently, and make better decisions. The people who understand buildings become more valuable, not less. Fourth, it has to be practical and measurable. I'm not interested in AI theater. What I'm interested in is capabilities that improve efficiency, reliability, consistency, and operational outcomes in the ways that customers can actually see and feel. And finally, it needs to be open and extensible. Niagara has always been an open ecosystem. Our role is not only to build useful capabilities ourselves, but also to enable our partners, developers, and customers to build trusted building data and workflows. So if I have to summarize my approach in this one line, it would be augment expertise, improve understanding, accelerate outcomes. This is how I believe AI can create meaningful value in building automation, and that's the lens through which we're approaching it within the Niagara framework. Everything I've described so far is not a departure from Niagara's strategy. It's a continuation of it. For more than 2 decades, Niagara has helped our customers turn complexity into outcomes, and that is exactly what AI should do as well. It starts by connecting systems. Niagara brings together diverse devices, protocols, and data sources from across the building, any vendor, any protocol. Then we create context. Raw data by itself has very limited value. When that data is organized, normalized, and modeled, it becomes trusted context about how the systems within the buildings actually work. Next, we enable workflows. That context is turned into automation, applications, custom logic, and operational processes. This is where data becomes action. Those workflows drive outcomes, better efficiency, better reliability, better sustainability, better occupant experience, ultimately, better building performance. And now, we add the next step. Amplify expertise with AI. AI becomes another tool in the Niagara framework that helps people understand faster, decide better, and act with greater confidence. So the key point is, AI extends the Niagara toolset. It does not replace people, it does not replace the platform. And that is why AI feels like such a natural fit for Niagara. So far, I've shared how I think about AI strategically. Now let me make that more concrete by showing a few examples of this direction and how it's beginning to take shape in the Niagara framework. Now these aren't just theatrical concepts. We have working proofs of concepts for all 3 of these, and some of you may have seen them in demonstrations at Niagara Summit a few weeks ago. They're also currently in various stages of development for general availability. The first example is Ask Niagara. You can think of this as an AI assistant designed specifically for Niagara, built right into the Niagara Workbench. Its goal is to help users more efficiently and more effectively within the Niagara environment by providing contextual assistance, helping with troubleshooting and accelerating learning and configuration. For experienced users, that can mean getting answers faster. For newer users, it can shorten that learning curve significantly. The next example is the MCP service. MCP, or Model Context Protocol, is emerging as a standard way for AI applications to discover and interact with external systems. In practical terms, this would allow Niagara to expose governed tools and data to AI workflows in a structured, secure, and permission-based way. The important point is that this is not uncontrolled AI access to buildings. It is standardized, governed access under the customer's control. The third example is IntelliDetect. This capability is focused on helping users analyze alarms, history, metadata, and system context to identify likely root causes of those alarms and surface actionable recommendations. In other words, helping users move more quickly from something's wrong to here's what is most likely happening and what to do next. So taken all together, these examples illustrate the broader objective: augment expertise, improve understanding, accelerate outcomes. That is the practical role I believe AI should play within the Niagara framework. So I've talked about strategy and examples. This slide shows how the Niagara ecosystem provides the technical foundation that makes all of this happen. At a high level, Niagara connects systems, creates context, and securely makes that contextualized data available to applications and services, including AI-powered applications built by Tridium and our partners. At the foundation is the Niagara framework running on-premise, at the edge. And this is where we integrate systems, normalize data, control equipment, generate alarms, historize data, visualize information, contextualize assets, and analyze building behavior. This is where raw data becomes structured and meaningful. Many of us have been doing this for a very long time. The connection between on-premise Niagara systems and the cloud is handled through secure outbound HTTPS using Niagara Cloud Connector. This minimizes networking complexity while keeping the customer in control. Niagara Cloud and Niagara Data Service build on that foundation. Niagara Data Service is our preferred method for securely exporting trusted, contextualized building data to the cloud. That includes semantic relationships, time series histories, alarms and events, all under secure, governed, and authorized access. Today, authorized applications can access this data through APIs. Looking forward, MCP service is an important evolution that will make Niagara even easier for AI tools and agents to discover and interact with a standardized, governed way. On top of that foundation, Tridium and our community partners can build AI-powered applications and services. Examples include Ask Niagara and IntelliDetect, and third-party applications that can create additional value from trusted building data. And this really is the architectural story. Niagara is not simply a source of data. It is a platform and ecosystem that integrates systems, creates trusted context, and enables secure innovation. The foundation is what makes AI possible in real buildings. So, what does this mean for integrators and owners? It means the fundamentals matter now more, not less. AI does not remove the need for good integration, good programming, good metadata, good histories, good cybersecurity, good governance, and human expertise. It raises the value of all those things. For integrators, that means your knowledge of real buildings becomes more valuable. For owners, it means the quality and trustworthiness of your building data matters more than ever. And for Tridium, it means that our job is to help make Niagara data, workflows, and expertise more useful through practical, secure, and governed AI-enabled capabilities. So, if I leave you with one thought, it's this: AI does not replace the fundamentals. It amplifies the value of getting them right.